Hello my dear class 10 students, how are you all? I hope you're doing amazing. This is your Ekta ma'am here. In this video, we are going to discuss the top 20 case-based questions from the section B of your science exam, that is chemistry. Yes my dear kids, every year 1 or 2 case-based questions come in your exams carrying 4 to 5 marks, so you should not avoid them and practice them regularly. Let's begin. First question. Whenever you read, see these kind of questions, try to read it properly once or twice, and then whatever observation, whatever thing you can draw from the given part, you need to write that down. You write that down that this is given and this is I infer. Your own inference should be written there. For example, in this question, a metal M reacts vigorously with water. So we kind of know that it is sodium, right? So just write in your inference that it is sodium. Question mark. Maybe or may not be. Then it reacts with water to form a solution S and a gas G. So there is a solution and a gas. The solution turns red litmus to blue. That means the solution S is basic, right? Write this in your inference also. S is basic, or S equals to base. Then you have gas G is lighter than air and burns with a pop sound. So you know pop sound, only one gas burns with a pop sound, that is hydrogen gas. So that means G is hydrogen, right? Next is metal M has a low melting point and is used as a coolant in nuclear reactors. So till now if you do not know that, but you do know that this statement clearly indicates it is sodium. This statement clearly indicates it is sodium. Then we have hydrogen gas also, plus the solution formed is also basic. So these all confirms our doubt that this is sodium. This is rather sodium. And when sodium reacts with what? Water, it forms sodium hydroxide and hydrogen gas is evolved, right? Clear? And this is basic. Clear? So that means the metal M is sodium, the solution S is sodium hydroxide, and the gas G is hydrogen. Clear? So that what was given to you, this was given to you, and this was what you inferred. This is how you inferred or analyzed your question and solve your case-based questions, and hence you get your 4 or 5 marks. Okay? So do not worry. First of all, every time clearly read your questions, the answers for case-based questions, the answers and the hints are there in the question itself. So you get your answer from the question itself. Okay? Rest your knowledge is also important so that you can connect the dots. Next question. Metals produced by various reduction processes, they are not pure, they contain impurities. So in this question we are talking about the process electrolytic refining. So in your mind the picture should be clear that yes, in electrolytic refining we have a cathode, we have an anode, and what are they made up of? So anode is made up of impure metal rod. It is made up of impure metal rod. And cathode is made up of pure metal rod. Pure metal rod. Okay, now let's see the question. Cathode and anode, correct. Cathode is pure. If copper is the metal, then impure copper is the anode, and pure copper is the cathode. Next, name the solution used in the above process. Again, we have a salt solution, soluble salt solution of that particular metal only. Okay, so in here we will have copper sulfate. Copper gets refined electrically. When you pass electric current, what will happen? That anode, impure metal rod at anode starts breaking down. The solution dissolves in the metal dissolve in the salt solution. From the salt solution, an equal amount of metal deposits on the cathode, and that's how you get your pure metal. You have 2 beakers. Let's say one contain copper sulfate and the other contain, see, A and B containing copper sulfate solution. When you put in one solution, you both have copper sulfate solution. Clear? A and B both have copper sulfate solution. Both copper sulfate. Okay, now what would you observe after 2 hours if you dip a strip of zinc in beaker A and a strip of silver in beaker B? So when you in beaker A, let's say this is A and this is B, if you add zinc and here if you add silver, what will happen? As we know, zinc is more reactive than copper. It will displace copper from its compound. So what we will get? We will get the deposition of copper on the zinc strip. The deposition of copper on the zinc strip, and here you will see there is no reaction. There will be no reaction. Why no reaction? Because copper is much more reactive than silver, thus silver cannot displace copper from its compound. Next question, study the following table. Now see, if it is visible, you have four metals A, B, C and D. These four metals are showing reacting with four different salt solutions: iron sulfate, copper sulfate, zinc sulfate, silver nitrate, and they are showing different reactions. The question is, name the most active metal. The most reactive will be the one which will displace most of them, right? That means it is lying at the top of the reactivity series and everything is lying below it. Only then will it be able to displace all the other metals, right? So here no reaction, displacement. So let's see. This is the least reactive. This is not the answer. Here also it is also reacting with silver, only reacting with silver. That means it is not that reactive. It is only more reactive than silver. B is able to displace iron sulfate. So that means B is more reactive than iron. A is able to displace copper. That means A is more reactive than copper. Now see, here you can see the pattern. Iron is more reactive. Iron is the most reactive. In between, among iron, copper, silver. Among iron, copper, silver, iron is the most reactive, right? And if something is more reactive than iron, so that means it is the most reactive in among these, right? We are discussing only these four metals, right? So the most active will be B, least active will be D, because it is not reacting with any one of the salt solution. Arrange the metals in the increasing order of the reactivity. Least will be D, first will be B. After that, copper and silver. Copper is more reactive, right? And if something is more reactive than copper, that means it is obviously more reactive. This is the final order. Now, container of which metal can be used to store both zinc sulfate and silver nitrate. So if we are talking about zinc sulfate, so something that is less reactive than zinc sulfate, right? So that it does not react with the zinc sulfate solution. Similarly, if we have a silver nitrate solution, so a beaker that is a metal that is less reactive than silver nitrate should be there, so that it does not displace silver nitrate. We want our silver nitrate and zinc sulfate safe. Okay, so what we will do, we'll go with the least reactive metal, and the least reactive is D here. Okay, that's how you think. Okay, you do not have to wait or waste your too much time. You think rapidly, and that's how you get error and trial, hit and trial, you say, right? Error and trial method. So you think of an answer, then you write a question mark, and then you, in the next sentence, you might find your answer. Okay, next question, it is talking about electrolytic reduction. It should be clear in your mind what is electrolytic reduction. It is used for highly reactive metals like sodium, potassium, calcium, right? Why can't we reduce oxide of sodium using carbon? Because sodium oxide, you know that, right? Sodium has more affinity, more need for it, it forms a bond with oxygen more strongly than carbon. Okay, it is more reactive with oxygen than carbon. Okay, thus carbon cannot displace oxygen, right? Thus carbon cannot displace oxygen. Clear? Next is steps involved in the extraction of sodium. So we have two things. We have an anode and we have a cathode. We have an anode and we have a cathode. What is happening at anode? At anode, Na positive, add 1 electron and we are getting sodium metal at anode, right? At cathode, chlorine Cl minus is losing an electron, and we are getting Cl. Okay, if 2 are there, then obviously we will get Cl2. Clear? Next is why we use molten, this is important, why we use molten silver, we use molten sodium chloride, not aqueous sodium chloride. That is why, because molten sodium chloride, in molten sodium chloride you have sodium, right? When you have aqueous, you have water. Aqueous means you have water, and in water you have hydrogen and oxygen. So here the hydrogen will compete with the sodium, and at anode instead of getting sodium we will be getting hydrogen. At anode instead of getting sodium we will be getting hydrogen. Thus this is not preferred. Thus aqueous sodium chloride is not taken. Why? Because sodium and hydrogen will compete, and hydrogen will be there at anode instead of sodium, and we want sodium. That's what the main purpose of this process is. Next question. Alloying, we know why we do alloying, to prevent the rusting, right? So what is rust? This is rust, right? Fe2O3 dot XH2O. X means the number of water molecule can be anything, 1, 2, 3, whatever you want, okay? This is the common formula of rust. This is rust, chemical formula of rust. Now what is the chemical name? This is called hydrated iron oxide. Hydrated iron oxide. And the oxidation number is 3, so you can add 3 also. But if you do not worry, it is still correct. Define galvanization. So galvanization means there is a coating of zinc on any iron surface. Because zinc is more reactive than iron, it will get corroded, but the inside iron will be safe. Important alloys containing copper. Name 2 important alloys containing copper. We have copper plus zinc, which is brass. Then you have copper plus tin, which is bronze. What are alloys? Alloys are homogeneous mixture. Remember the thing? They are a homogeneous mixture of metals, homogeneous mixtures of metals and metals, or metals and non-metals. There could be a metal or a metal plus non-metal also. Both are called alloys. They are a homogeneous mixture, okay? That means you mix them in a particular quantity. Uniformly you mix them, and you mix them in particular quantity, right? For example, 60, 40, 70, 30, that percentage is predetermined. Next question. There is a salt of the metal. When it is exposed to light, it splits up as metal and gas, okay? It splits up as metal and gas. The hint is metal M is used for making ornament, so either it will be silver or it will be gold. But we know, we have not studied any compound of gold which decomposes. What we have studied, that there is this compound which do decompose, and it is also used in black and white photography, right? It is also used in black and white photography. So that means M is silver, X2 gas is chlorine. Also one more hint is there, that your gas is used in making bleaching powder, my dear kids. So always read your questions. So gas is used in making bleaching powder, that is correct. Chlorine gas is used in making bleaching powder. This is the formula of bleaching powder. Just follow this. It is written in the NCERT. The CBSE will consider this as the correct only. Next is name the metal salt X. This is the metal salt MXAgCl. Name 2 solutions from which mixing you can produce this salt. So we have, let's say we have silver nitrate and sodium chloride. If we react these 2 solutions, if we mix these 2 solutions, what do we get? We get silver chloride and sodium nitrate. And this is what we need, right? Next is what type of chemical reaction takes place when salt is exposed to light. What is this reaction? This is photolysis. This is photolytic decomposition, you can call it. Photolysis or photolytic decomposition. We talk about decomposition. There are 3 types of decomposition, right, my dear students? First is thermal decomposition, then you have electrolysis, then you have photolysis, right? So this is photolytic decomposition. Next question, when a black metal compound is heated with a colorless gas, it forms a compound metal X, and this is formed. We know that it is written here that metal X is red brown, and we know that only one metal that is red brown, copper. That is copper, right? And it does not react with dilute acids at all. This gas Y2 is prepared by the action of dilute acid or any active metal. We do not know anything, but we know that it is a liquid at room temperature, and it turns anhydrous copper sulfate blue. Copper sulfate is blue because of water, right? Because of those 5 water of crystallization. So that means this Y2O is H2O, right? So X is Cu. What is Y2? Y2 is this gas, right? That means Y2 is hydrogen, compound XO. XO is copper oxide, because copper oxide is black in color, right? And this Y2O is water. Now how do you, when you heat copper oxide with hydrogen gas, what do you get? You get copper plus water. This is the reaction. Simple, clear? Next question. Gas is a major cause of global warming. Which gas is the major cause of global warming? Carbon dioxide, right? So we know that gas A is carbon dioxide. Next is it reacts with the hydrogen oxide, an oxide of hydrogen, that is B, and it forms combined with an environmental factor, a green material D, to form 6 carbon compound gas F. Okay, the gas F is necessary for breathing, so we know gas F is oxygen. And green materials, natural compound, isn't something that plants do. They combine carbon dioxide. This is the reaction, right? Carbon dioxide with water. Let me balance it first also. In presence of sunlight, right? This reaction happens in presence of sunlight. Clear? What is happening here? We have a carbon, a gas A, which is responsible for global warming. It combines with hydrogen oxide. This is oxide, right? There's oxygen, oxide of hydrogen, in presence of an environmental factor C. This is the environmental factor in presence of sunlight. Photosynthesis always happens in presence of sunlight. And a green material D to form. What is the green material D? Chlorophyll. That green material is chlorophyll. To form a 6 carbon organic compound E and a gas F. Gas F, this is the 6 membered carbon compound E, and this is the gas F that is required for breathing, that is oxygen. Clear? So what is the gas A? Gas A is carbon dioxide. Common name of B, which is B? Water. Common name is water. What do you think would be C? C is sunlight. C is sunlight. What is the material D? Where is it found? Material D is, what is D? D is chlorophyll. D is chlorophyll and it is found in plants, chlorophyll plants. Name the organic compound E. What is the organic compound E? Glucose. And what is the gas F? Name the natural process during which it is released. So the process is photosynthesis and the gas is oxygen. And the process is photosynthesis. Next question. A silvery white metal taken in form of ribbon, ignited, dazzling white flame. These two things will be sufficient, should be sufficient for you to guess that this metal is magnesium, because it burns with a dazzling white flame in presence of oxygen, and it gives a white powder of magnesium oxide. This is Y, this is X. Clear? It combines with a gas, okay, the burn. When water is added to powder Y, this it dissolves partially to form another solution Z. Now see, when you combine water with magnesium oxide, it is metal oxide, right? And metal oxides are basic in nature. It will form a base, magnesium hydroxide. This is the base. Or what is the common name of this base? Milk of magnesia. It is used as a good antacid. Which substance metal combine to form powder Y? Metal X combines with oxygen. With oxygen to form powder Y. What is substance Z? Substance Z, name and domestic use of substance Z. Substance Z is magnesium hydroxide, right? Because it dissolves partially in water to form this substance Z. And the common use, we use it as an antacid. Balanced chemical equation, this is the balanced chemical equation. Clear? So when you are studying it, when you are reading the question, read it properly. Read it twice first of all, and then see the hints. It is written clearly. For case-based questions, the hints are all in the questions itself. Okay. Next is, we know that the construction material, normally the thing that we use for construction is limestone, right? Calcium carbonate. This much we know. Okay, after that, let's see what is happening here. When you heat strongly, it decomposes. So when you heat it strongly, it decomposes, and a gas R and a solid Q. So when you heat it, it decomposes at calcium oxide and carbon dioxide. So this is Q, solid, and this is R, gas. Clear? When solid Q, which is calcium oxide, reacts with water, reacts vigorously with water, exothermic process, and if you combine it with water, we get calcium hydroxide. And lot of heat is released. This is an exothermic process. Clear? It combines with water to form, this is the substance S. Next is when gas R is passed into a clear solution of substance S. When gas R, this gas R, carbon dioxide, it turns a white precipitate of T. So when you pass, again, calcium hydroxide you have, if you pass carbon dioxide, we get calcium carbonate. We get calcium carbonate, which is milky white, you can say, milky. This is T. right? So the substance T has some same chemical composition as the starting substance. So that means T and P are same. So what is the substance P? Calcium carbonate. We have answered all these questions. I hope it is clear. What is this clear solution? The S is this clear solution calcium hydroxide, right? Because it is a base. Next question. White shirt, yellow stain, curry. We have, okay, we know the yellow stain turned reddish brown. So firstly, the indicator that was used is turmeric. The indicator that was used is turmeric. And what is the color change? So initially turmeric was there on the shirt, right? It was yellow color, acidic medium, right? And when we added a base, it turned reddish brown. It turned reddish brown, but when we washed it with water, the base washed away. And because the base is not there, it will turn yellow again. Clear? Now what is the nature of the soap? Again, soap is basic. Only because it was basic, that's why the turmeric turned reddish brown in color. Next question. You have been provided 3 test tubes. So one, you are given actually litmus paper which is blue in color. You are given a blue litmus paper and 3 solutions. One is acid, one is base, one is neutral. So see, if you are given a blue litmus paper, acid will turn blue litmus red. Acid will turn blue litmus red. Clear? Now, if your litmus paper is red now, you can use it to check if there is a base or not, because bases will turn red litmus blue, right? But for neutral solution, there will be no change in the litmus paper. There will be no change in the color of litmus paper. Clear? Next question. We are given which is highly weakly alkaline. Weakly alkaline will be which one? This one, right? Neutral is this one. Strongly acidic, 1. Then you have strongly alkaline, 13. Weakly acidic, this is 5, which is close to neutral, right? It is very weakly acidic. 5. Done. This one was easy, right? Next question. Solution A turns universal indicator blue to purple, whereas solution B turns universal indicator orange to red. That means solution A is basic and solution B is acidic, and solution B is acidic. What will be the action of solution A on litmus? So solution A is basic, right? It will turn the red litmus blue. It will turn red litmus blue. And what about solution B? Solution B is acidic, so that means it will turn blue litmus red. Now name any 2 substances which can give solutions like A. A is a base, right? Any base you can say sodium hydroxide, calcium hydroxide, these all are bases. Then acids may you have hydrochloric acid, nitric acid, these all are acids. What sort of reaction take place when acid and base reacts? We get neutralization reaction. And what is the product of neutralization reaction? Salt and water. Correct. Next question. Hydrochloric acid reacts with metal X and forms a gas Y. First of all, you know, whenever acid reacts with metal, whenever an acid reacts with metal, we get salt plus hydrogen gas. Salt plus hydrogen gas. That means metal I don't know, but I know that gas is hydrogen, which burns with a pop sound. It is also written, confirming our doubts. Sodium hydroxide solution also reacts with the same metal X. So there is this metal which is reacting with both acids and both bases. So it is an amphoteric metal, right? It is amphoteric in nature. So one we know that is zinc. It can be zinc also, right? Because here zinc, aluminum, lead, I am taking zinc. Okay. Okay, so that metal can be zinc, aluminum or lead, right? I'm taking zinc. It is easy, no matter, okay? No worries. See, when zinc reacts with a base, we get a salt and hydrogen gas is evolved. Similarly, when zinc reacts with an acid, again we get a salt and hydrogen gas is evolved. Clear? These are the reactions. Simple. The metal is zinc and the gas is hydrogen, because whenever a metal and acid or metal or base reacts, we get a salt and hydrogen gas is evolved. Clear? The hint was that it is reacting with both acids and bases. Next question. A compound X which is prepared from gypsum has the property of hardening when mixed with a proper quantity of water. So it is a gypsum compound. We know what is gypsum. This is gypsum, right? And what is the compound of gypsum that instantly hardens when we add water to it, that is POP, plaster of Paris. And what is plaster of Paris? It is calcium sulfate dot half H2O. So the compound X is POP. Chemical equation for its preparation. How do you prepare it? You dehydrate it, heat it up to 100 degrees Celsius, right? And it loses its 1.5 water of crystallization. It loses its 1.5 water of crystallization, and that is POP, and that is how you get POP. Purpose, it is used in hospital for fracture bones, to correct the fractured bones, right? It is also used in floorings and for ceiling designs. It is used for those purposes also. Next question, a white powdery substance, strong smell of chlorine is there. Okay, it is used in disinfecting drinking water supply. We know bleaching powder is there, right? Bleaching powder is there. It is used to disinfect. Bleaching powder is used to disinfect drinking. Disinfect, right? It is a disinfectant, right? So what is bleaching powder? CaOCl2. This is bleaching powder. So what is this substance? A white powdery substance. This is bleaching powder. Its chemical name is calcium oxychloride. Calcium oxychloride. There is one more name. Do not need to use it, but calcium hypochlorite. Calcium hypochlorite. It's just a name. Like the chemical reaction, how do you prepare it? Take calcium hydroxide, right? You take calcium hydroxide or slaked lime, and from slaked lime you pass chlorine gas. If you pass chlorine gas through slaked lime, what do you get? You get plus. Clear? That is bleaching powder. That is bleaching powder. Next question, when chlorine and sodium hydroxide being produced during electrolysis, when chlorine gas and sodium hydroxide which are produced during electrolysis, they combine, what do we get? We get sodium hypochlorite. We get sodium hypochlorite. This is sodium hypochlorite. This is similar to bleaching powder, but instead of using calcium, we are using sodium. I hope it is clear. This is calcium hypochlorite, and it is also a bleaching powder. It is also used for bleaching, okay? Whenever there are some two type of bleaching powders out there. You have one calcium one, and this is the other sodium one. Next question, there is an organic compound with the formula C2H4O2. We do not know much, but we do know that it is an acid, and only one acid is possible with this formula, which is CH3COOH, acetic acid or ethanoic acid. Clear? So when you combine ethanoic acid with methanol, what do we get? Acid, alcohol in presence of a basic medium. In presence of an acidic medium. In presence of an acidic medium, it is esterification, right? Whenever an acid and alcohol combine in presence of an acidic medium, we get an ester. So the ester will be CH3COOCH3, methyl ethanoate. The ester will be methyl ethanoate. Plus water will be there also. Clear? So the compound X is acetic acid, compound Y is ethanol, and when you heat it, compound Y is methyl ethanoate, and write a chemical equation involved. This is the chemical equation in presence of sulfuric acid. In presence of sulfuric acid. Okay? Easy, right? You should practice these, and that's how you get a hold of these kind of questions, that how to approach them and how to solve them, because these comes in these paragraphs where you have the answers, and under these paragraphs you have the questions. Next question and the last question. Should I give you the homework? Okay, I'll solve 2 and 1 I'll give you as the homework. So for alkanes, I know the general formula is CnH2n plus 2. For alkenes, the general formula is CnH2n, right? So molecular formula of a 20 carbon compound containing 20 carbon atoms. That means the N is 20. So for alkane, it will be C20H2 times 20 plus 2, which is C20H40 plus 2, which is 42. Clear? For alkene, C20, H2 times 20, which is C20, H40. This is the molecular formula. For the alkyne, you have the homework do for the alkyne, and solve all these questions once again on your own, my dear students. Okay, that was it. All the best for your boards.